Hello everyone, this is Jay from BTYT Tech Library. Today we are going to overview Rocket Web Framework. According to multiple sources, including the Stack Overflow Developer Survey, Rust has been the most admired programming language over the years. In my case, the first thing that comes to mind is memory safety through concept of memory ownership and borrowing. With this concept, Rust can take on both performance and safety without the garbage collector. It's not a secret Rust has relatively steep learning curve than other high-level programming languages. But I'm intrigued to use Rust to create web application, which is not system programming area, and looking for a web framework like Spring Framework from Java Virtual Machine or Rails from Ruby. So let's check together how Rocket works and what it's capable of. When a Rocket web application receives a request, it follows a straightforward three-part process that begins with a request and ends with a response. The first step is validation. Rocket validates a matching request by ensuring that all of the types in a given handler can be read from the incoming request. So when it gets a request, it checks HTTP method, URL path, and type. Next step is processing. An arbitrary handler processes the request. This is where most of the business logic in an application resides. And in Rocket, handlers are simply functions that return type with implementing responder trait. The final step is response. Finally, Rocket responds to the client by transforming the return value of the handler into an HTTP response. The HTTP response generated from the returned value depends on the type's specific responder trait implementation. That's how Rocket works. Now let's check its life cycle. Rocket's main task is to listen for incoming web requests, dispatch the request to the application code, and return a response to the client. Routing. A route is a combination of a set of parameters to match an incoming request against. A handler to process the request and return a response. A handler is simply a function that takes an arbitrary number of arguments and returns any arbitrary type. Mounting. Before Rocket can dispatch to a route, the route needs to be mounted. Routes be listed via route macro. The mount method, like all the other builder methods on Rocket, can be chained any number of times, and routes can be reused by mount point. Launching. Rocket begins serving requests after being launched, which starts multi-threaded asynchronous server and dispatches requests to matching routes as they arrive. There are two mechanisms by which a rocket can be launched. The first and preferred approach is via the launch route attribute, which generates a main function that sets up an async runtime and starts the server. The second approach uses the rocket main routes attribute. Rocket main is useful when a handle to the future returned by launch function is desired, or when the return value of launch function is to be inspected. Futures and async. Rocket uses Rust futures for concurrency. Asynchronous programming with futures and async await allows route handlers to perform wait-heavy I/O, such as file system and network access while still allowing other requests to make progress. Fairings. Fairings are Rocket's approach to structured middleware. Middleware facilitates the separate of concerns making it possible to add new features or modify behavior without altering the underlying codebase. Rocket's fairing are a lot like middleware from other frameworks, but they bear a few key distinctions. Fairings cannot terminate or respond to an incoming request directly. Fairings cannot inject arbitrary non-request data into a request. Fairings can prevent an application from launching. Fairings can inspect and modify the application's configurations. Finally, like other awesome frameworks, Rocket supports testing, configuration, deploying. Today, we dragged the ingredients of Rocket Web Framework. I think our next step is to cook a basic tutorial to see what it feels like.